myself Dr. Ganesh Miriyala from Department of ECE, MLR Institute of Technology. And in this lecture, we are going to be study about the what is a linear and time invariant system in continuous domain and in discrete domain. So first first we will see the continuous domain. So what is meant by generally linear and time invariant system? If you want to say a system must be a linear and time invariant system, and the system must satisfy the linearity and time invariant property. If a system satisfies the linearity and time invariant property, then we can say that particular system is called the LTI system, or you can call it as a linear and time invariant system. So what is the condition for the linearity? If a condition for the linearity is superposition principle, that is, if you apply x1 of t is input to a system, then its corresponding output is y1 of t, and if you apply x2 of t is input to the system, then corresponding output is a y2 of t. Then similarly, this is called it is a additivity, and the second one, it is a homogeneity. Homogeneity is if I multiplied some constant a into x of t, and my output must be some a into y of t. By combining these two, we are calling it as some alpha into x1 of t plus beta into x2 of t as my input to the same system. If I am able to write some alpha into y1 of t plus beta into y2 of t, then this is called the linearity property. It is a linearity property. Similarly, if I evaluated y of t at t is equals to t minus t naught, and same y of t at x of t replaced by x of t minus t naught. If these two are equal, then this is called the time invariant system. So it is a time invariant system. If any system satisfies this linearity and time invariance property, then the corresponding system we can call it as a linear and a time invariant system. So if you look into any system, so its representation is like this. H of t is a system model, and you can call it as a y of t is a output when comes to the x of t is a input. So how to evaluate this output y of t? Then y of t is nothing but the convolution of the input signal and a system function. So it is a system function. X of t is input and convolution with h of t. This is the response of the system. So y of t is a response of the system. That response is nothing but the convolution of the two signals. One is x of t input signal, and second one is a system function. It is a system model, sometimes we can call it as, and system function also you can call it as. So then how we will evaluate this convolution property means, suppose if you want to find the convolution of the signal, we can evaluate from minus infinity to infinity x of tau and h of t minus tau d tau. If you use this formula, then you will get the convolution of the signal x of t with a h of t. Is it clear? Now this is a convolution property of del of t. If you multiplied any signal x of t with convolution with del of t, then you will get it's a response. Del of t is always we are treating it as a 1 for this particular signal, so that you will get, when you are giving the input as an impulse, then your y of t is nothing but exactly it is a h of t, because this convolution of x of t will make equals to the 1. So in time domain, y of t is equals to h of t when input x of t is equals to del of t. So this is a del of t property. You can call it the impulse signal property, right? So then how you are going to be evaluate? Is there any specific process or methods are there to evaluate the convolution? Then we will see graphical method is there. First one we are to see graphical method. So we are going to be see the graphical method for evaluation of convolution. Graphical method for convolution. So in this one, what is the process? How we are going to be see? The first one, if I want to do the convolution between x of t and h of t, what is the graphical process? This to convolve these two signals. The first one, step one, you should do. First one, it is obtain the limits. Obtain the limits of the resultant signal. Resultant signal, that is y of t. As I mentioned, y of t is equals to x of t convolution with h of t. Then how you are going to be obtain the limits for this one? For suppose x of t and h of t both have some specific limits, then that limits for the y limits, now your y limits must be sum of lower limits of x and h and sum of upper limits of x and h. So that means you must add the lower limits of x and h, which is the lower limit of y, and sum of lower limits of upper sum of upper limits, then you can get the upper limits for the y of t. So then these are the limits for the y of t. This is step 1. Now step 2, you are going to be change the axis from t to tau. First one is we'll find the limits. Second one, change the axis from t to tau. Next, step 3, folding or flipping. You can call it as a flipping also. You can fold or flip, whatever it may be. So you can call fold the signal, that is you will get the minus tau. Flip means you will get the minus tau. When you are changing the axis, you will get the signal x of tau and h of tau, and one signal you supposed to fold it. I am doing at this moment h of minus tau. So that means I can do only one signal. Next, step 4, multiply the given signal in the proper interval. So wherever the signal will get the intersect, then you can multiply those signals. So finally, step 5, then integrate those two signals. So integrate those two signals. First one, we are obtaining the limits. Second one, you are changing the axis from t to tau. Next, third one, flipping the signal. Only one signal. Among those two signals, we are flipping the one signal. Next one, multiplying those two signals with respect to the limits. Then finally, we are doing the integration. Then you will get the original, what do you call, convolution of the signal. This is a process for the convolution. So we'll see with some proper example, then such that you can get the how we are going to be evaluated. So see, let's take one example. For suppose this is my signal. So look at the signal, time, and this one I am taking it is h of t with the amplitude of 0 to amplitude is 2. Now another signal I am taking it is x of t. This is a x of t signal. The amplitude is in between 0, 1, 2 and 3. Amplitude is 1. So these are the two signals which we are going to be convolved with. And the first step we need to do, first one, it is find the limits. What is a resultant signal? Then y of t you need to find by using the graphical method, that is x of t convolution with h of t. So what is the convolution property? In definition, minus infinity to infinity x of tau h of t minus tau d tau. This is a y of t. This process we are going to be evaluated by using the graphical method. So first of all we are finding the limits. What are the limits? Sum of lower limits. Sum of lower limits means this is a lower limit of this signal and upper limit is 1. Here it is lower limit is 1 and upper limit is 3. So sum of lower limit means 0 plus 1 in between t. This limits of y limits. Those are the y limits, and upper limits are 1 plus 3. That means 1 less than t less than 4. These are the limits. First step it is these are the limits for y of t. That means your response y of t you will get in between the 1 to 4. This is a step 1. Now coming to the step 2, change the axis from t to tau. So the same signals I am taking. First one, this is axis is tau and the signal is now h of tau. So there is no change in amplitude. So we write at 0 to 1 and amplitude is 2. The same thing I am trying to do here. It is here it is 1 to 3 and axis I changed. The signal is now x of tau. Here it is we will have the x of t in a first method. In a first line you have the x of t. Now we change the axis to the x of tau. Now third one we need to fold it. You can fold either x of tau or you can fold either h of tau or x of tau. Okay. So for the instant I am folding the h of tau, first one. So for my choice I am taking the folding of signal h of tau. The folding means the signal will be, you will get at the in reverse manner. So the signal is look like this, 0 and minus 1 and amplitude is 2 itself. Now the signal representation is h of minus tau, and this process the signal is it's look like same only because we are not folding anything over there. The amplitude is 1 and the signal is x of tau only, and 1 and 3. So these are the now at present in third step. So what is the next step we are doing? And next step we are doing for the h of tau. We already chosen. In my case I have taken h of tau is my preferable signal. So the next one I am trying to do it is shifting by t units. Shifting by t units. So how the signals look like? Now this is a tau. My signal shifted by t units. That means for the first one 0 plus t it is t, and t minus 1 plus t, then I can write it as a t minus 1. So at this one, so amplitude is not going to be changed at all. That is a fixed one. This value is 2. Now this signal name is h of t minus tau. The signal name is h of t minus tau. Now what about the x of t? We are not yet done any changes in x of t, so that we are getting the signal is x of tau only as it is. Now the amplitude is 1 only. The time intervals from the 1 to 3. So this is the step 4. Now step 5, what we are going to be do? So we will do integrate. So first of all, one by one we are going to be integrated. So that is first one I am trying to multiplication in the step 5. It is step 4. Now it is step 5. Step 5 it is, which is the integration. So in this integration, so we already shifted time value. It is with the tau value with t units. So that if that t, whatever the shift we have taken, if the t in case 1, I take case 1, if the t is in between 1 to 0, that means in between 0 to 1, how the signals look like? See, I am trying to multiply those two signals and integration. So this is x of tau, this is x of tau. You will have 0 to, this value is 1 to 3. Right? Now as I mentioned, the shifting t value is in between 0 to 1, that means below this one. let us take the signal is like this at this moment, that is t minus 1, this is a t, amplitude is 2. So we need to multiply these two signals. So if we multiply these two signals, is there any intersection portion? There is no collapse and there is no intersection between these two. If you multiply the same signal, then you will get the 0 itself. So for t is equals to, for t in between the 0 to 1, the resultant signal y of t e must be 0, because there is no intersection portion. If you have any intersection, then you can multiply those two signals, then you will get it. So this is a case 1. Now I am taking case 2. Oh, if the case 2 is, if my t is in between 1 to 2, if t is in between 1 to 2, how the signals look like? Now the time t, and this one is 1 unit, amplitude and 1 and 3, this value is 0. Now as I mentioned, t must be, that means this t must be in between 1 to 2, that means let us take this value is 2. Now 1 to 2 means I will get the t value over, let us in between over here. So this is my t. So this is a t, so that the signal is look like this now. Okay, the signal is look like, what is this value? This value is t, this value is t minus 1, because we already taken t minus 1 t. This is t minus 1, this value is t now. Now what is the intersection area? This is the intersection area. So this thing is a intersection area. So in this case you need to evaluate the integration portion. Integration means y of t, where integral minus infinity to infinity. But what the limits we have? From 1 to t only we will have. From 1 to t, and definition is integral minus infinity to infinity x of tau h of t minus tau. H of t minus tau. What is the x of tau now? X of tau at 1 to t, the value is, x of tau is equals to, value will have 2 only, magnitude is 2. Next, h of t minus tau, this is, x of tau is, value is 1 and this value is 1 and this value is 2. So in between x of tau you will get the value 1 multiplied by, and h of t minus tau, h of t minus tau value it is, h of t minus tau value it's maximum, you will have the 2 into d tau. If you evaluate it, 2 into t over the limits t to 1, which implies 2t minus 2. 2t minus 2, you can write it as a, if you take 2 is a common, t minus 1. T minus 1, this is for the case 1. So I am writing over here, for this one, y of t is 2t minus 1 in the interval 1 to 2. This is about the second one. Next, case 3. Case 3 you will have, if my t is in between 2 to 3. If my t is in between 2 to 3, then how the signal look like and how you are going to be evaluated. The same, 0, 1, 2, 3. Now my t is, I mentioned, t is in between 2 to 3. That means here you will get in between 2, this value is t. If this is t, where is t minus 1? You will get over here. This is a t minus 1. So where is the intersection portion? You will have the, this is the intersection portion. So that means you need to evaluate integration from t minus 1 to t only. T minus 1 to t. Same, y of t is equals to, the limits are from t minus 1 to t, such that you will get the value same. What is the x of tau? X of tau is value 1 amplitude, and h of t minus tau amplitude is 2. So 1.2 d tau, then which implies we will get the 2t over, 2 tau. This is a 2 tau, then over the limits, here it is also tau only. 2 tau, and the limits from t minus 1 to t. If you evaluate it, 2t minus of 2t minus 1, 2. So if you evaluate it, then 2t will get cancelled, minus into minus 1. The value is, you will get 2. So for this case, y of t is equals to 2. y of t is equals to 2. Okay, now I'll use this one. So in the next case, I'll take if case, that is 3. Now the case 4. Case 4, if my t is in between 3 to 4. So in this case, how the signals look like? So this is tau, right? Next 0, 1, 2 and 3, and this value is 4. Now t is in between 3 to 4. 2 to 3 is completed. Now 3 to 4. If it is in between 3 to 4, first one, this is a t. Now t minus 1 in between here. So this portion is a intersection portion, t minus 1. Now we supposed to integrate the signal over the interval from this point to this point, intersection portion. That means t minus 1 to 3. So then y of t I can write directly integral minus infinity to infinity. Instead of I am writing t minus 1 to 3, 1 to d tau. So that I can get 2 tau over the limits 3 to t minus 1. That means 6 minus, yeah, it is 6 minus 2 into 6 minus 2 into the value is t minus 1. So that I will get 6 minus 2t minus 2. That means I will get the 3 to the, okay, right, fine. So I'll get it is 4 minus 2t. If I take 2 is a common, then 2 minus t. So this is about the next one. That means at y of t is equals to 2 into 2 minus t. Okay. Now if you look at the case 1, if I look at the case 1, y of t equals to 0, I write case 1 C1 y of t equals to 0 when the limits are, you will check it one, in between 0 to 1. In between 0 to 1. If t is y of t, then y of t is equals to second case. Y of t is equals to second case 2t of 2 into t minus 1. 2 into t minus 1 in between 1 to 2. Next same y of t equals to 2 in between 2 to 3. Next y of t is equals to the final case, it is 2 into 2 minus t, where the value in between 3t to 4. Now y of t equals to 0 for t greater than 4, because if it is crossed, then you will get the no intersection between this this signal and this signal, so that we will get the 0. So this is about the entire y of t. Y of t is you will have the 4 cases, for 5 cases, 1 2 3 4 5 cases. So if you want to draw this signal, you just check it. T, and as I mentioned, the signal must be in itself. Initially we got the interval, time interval from the lower initial signal. It is y limits must be in between the 1 to 4, 0 1 2 3 4. So 1 to 4. Then from 0 to 1 you will get the 0, 0 to 1 you will get the 0. Next above 4 you will get the 0, right? The middle one y of t equals to 2, from 2 to 3 in this area. So that means around this area you will get the amplitude is 2. Then from 1 to 2 you will have the 1 to 2, you will have the 2t. That means there is a t signal, means ramp signal. And next one from 3t to negative 3 to 2, 3 to 4 it is a, you will have the minus 2t. That means negative ramp signal. You will get the negative ramp signal. So that if you multiply two rectangular signals with a different pulse, different widths, you will get the trapezoidal signal, and if you take the same time duration, that means if these two rectangular signals time duration is same, then you will get the triangle pulse, triangle signal. So in this process we are going to be evaluate the convolution process for the any two signal by using the graphical method. Okay, so what we studied, so y of t, we clearly mentioned it is a linear time invariant system. So what is meant by linear time invariant system? In this one it should obey the linearity, and second one it is a time invariance property. So based on one we studied about the convolution, linear convolution we can call it as a. Second one, graphical method we studied, graphical method, and by using the convolution process, that is y of t is equals to integral minus infinity to infinity x of tau into h of t minus tau. So for this one we have the some rules, that means steps which is involved in find the first one limits, second one change the axis, and third one fold it, and fourth one multiply it, fifth one integrate it. So these are the 5 steps which we involved in the graphical convolution. And next topic we will see the same convolution LTI system only, but in discrete process. This is for discrete signals. Thank you.